Three identical circles inside one large circle. Each small circle has radius 3. But here's the challenge. Can you find the exact red shaded area? Most people get stuck immediately. But one hidden geometry trick makes everything surprisingly simple. Now your turn. Pause here and try it yourself. Let's begin carefully. The three smaller circles are identical, and each circle touches the other two circles. That means the distance between their centers equals 2 radii. Now connect the centers. Notice something interesting. All three sides are equal. So the triangle formed here must be an equilateral triangle. Equilateral triangle side length equals 6 and each angle equals 60 degrees. Now comes the important geometry trick. The center of the large circle is also the center of the equilateral triangle. So, we need the distance from the center of the triangle to one vertex. From the right angle triangle. The distance from the large circle center to the small circle center equals to 2 times the square root of 3. When the lines is extended to the outer circle, the added length becomes equal to the other radius, which is 3. So, the total outer circle radius becomes the inner circle radius is 3. Now, let's calculate the area of the circle using the area formula pi r squared. Accordingly, area of the large circle becomes 131.270 square meter. Each small circle has radius 3. So, one small circle area equals to 9 pi. Accordingly, the approximate red shaded area is 46.45 square meter. Did you solve it before the reveal? Comment below, solve it, and subscribe for more geometry puzzles and maths challenges.